Hello everybody, my name is Altamush Khan. I am a video game director, video game designer, and game developer. I have 8+ years of experience in game development. And today I'm going to teach you how to make a very basic space shooter. Now, space shooters have been around since more than 30 years. And today we're going to learn how to make a very basic one. I'm not going to go into a lot of details because of time constraints, but hopefully you'll get an idea of how Unity works and how you can make a basic first-person shooter, basic space shooter inside of the Unity engine. So for that, I'd like to play the video where I've actually made the game, and I'm going to explain how I did it and how you can do the same thing. Okay, so the first thing that I'll do is what I did is that I went to my browser and I searched for the Unity engine. That's because we need to know how to download the Unity engine before we start building a game on it. And the Unity engine's website, you can find it easily if you search on any search engine. And I use Start Page, and this is the Unity game engine right here. So it's a real-time development game engine, and it can be used to make a whole variety of applications. Games are one of them. And you can see I'm scrolling through the website. This is the front page or the landing page of the Unity engine. And I'm actually going to take a look at the pricing plans just so that you know that Unity is actually a commercial engine. It's not free to use unless you have a personal license. But there are some limitations. When you have an individual license, you can only have an individual license if your organization hasn't made more than $100,000 per year. And then you can have this personal free license. So you can use Unity for free, but eventually you'll have to start paying Unity. And you can take a look at their licenses later. But you can see that per month is $150 if you buy Unity Pro. And that is only for the organizations that have made more than $100,000. So you will also need to sign in, and you will need to make an account to download Unity and to access all of its features. But right now, I didn't do that because it's not required. I already have Unity installed. So again, I'm just over here, I'm focusing on the personal license, and now I'm going to say download for Windows and download for other operating systems. You can see download for Windows, download for Mac, download for Linux. I use Arch Linux, so I use a package manager. I don't need to download it from here. I install Unity through the command line. And Unity does not install automatically. You have something called the Unity Hub, and you use the Unity Hub to install Unity. And the Unity Hub is kind of like a portal. It's a small application which lets you manage different Unity versions. So I'm actually over here, I'm showing how to download the Unity Hub on Windows, but since I don't have Windows, it won't work for me. This is how the Unity Hub looks like. And you can see all of my projects are over here. These are all of my projects. These are all of my clients' projects, actually. And it's a little bit laggy because the compositor is off right now, but it was smooth on my screen. That's only in the recording. So on installs over here, if I click this, you'll see the different Unity versions that I have. Now, I have them installed already, but you will have to click the install button on the top right to install the latest Unity version. There's also something called Download Archive, where you can download any version of Unity that you want. Before you download Unity, you will have to select the license. So you can go to the licenses, which is in settings, and select your license. Once you have a license, which will be personal, most likely, because you'll be using Unity for free, you can download any Unity version that you want. I recommend the LTS versions, not the current versions. And now we are going to select one of the templates called the 2D core, and I'm going to save the project and name it with the name that you'll see over here. I believe it's TBH Space Shooter Basic. So that's what I'm naming over there. And then I'm going to create the project. So I'm using the 2D core template to create this project. And you can see that I'm focusing on 2D core. These templates are given by Unity, so they're not like they're built into Unity, so you can use that as a base to create your game. So once you click create, Unity does its things. It does its thing. It creates its libraries. It starts creating the project, and eventually you'll see Unity open in front of you with nothing more, nothing, just a empty scene. And you can see that I was just testing whether it's working or not. And over here you can see that's initializing. So this is how you create a project in Unity, and then you get everything ready so that you can now begin working on the project. So right now you'll see nothing. It's going to be an empty, just an empty scene. This is a scene. In Unity, we have scenes, so that is a scene. You can see it's empty, there's nothing there, just a camera icon. And that little rectangle that you see, that is what the camera sees. So that little rectangle, that outline, that is what the camera sees. So these are all the tools that Unity has. I'm just going to select my layout, which I use. This is my personal layout, which is this. So this is the scene view, where you can see whatever you place inside of the game. That is the game view. So when you play the game, this is what you will see. And don't know where the cursor is. Okay, scene view, that's the game view. That is the hierarchy over there. This is over here, what I clicked is, this is to set the perspective of the game view. So you have different aspect ratios, and you can select whatever aspect ratio you want in the game view. Over here, I use the middle mouse to move the camera around inside of a 2D view, and I can also use the right click on the mouse to move the camera around or move the scene view around. That is the hierarchy over there, so whatever you place in the game is going to show up in the hierarchy. That's the console over there, so errors and every log is going to come over there. And over here, I switched back to default view because this is what you will see when you open up Unity first. That was my layout. I'm going to use my layout, but I'm just, over here, I'm telling what is the game view and the scene view. The scene view is up there. You can see the tab. The game view is here. I changed the aspect from free aspect to 16:9 because this is the aspect that usually games use these days. So that's the aspect ratio. Just to give you an idea that layout and this layout, it looks different, but everything is mostly the same. So once you're here, once we're back in my layout, which is the one that I use, and most professionals that I know use this one, because you can see the game view and the scene view at the same time, what I'm going to do is I'm going to show you the component system over there. So Unity has game objects, and those game objects have components that is on that side. Those components are basically kind of like blocks, or they're kind of like, well, they're components, there's no other word for it. Game objects simply have a transform component, and since this is a camera, it also has a camera component, which means you're telling Unity that this is a camera when you add the component camera to it. Over here, I'm showing the various tools, like the move tool, which is the one that we're using right now, and this will move the camera in a 2D plane, on a 2D plane. So right now, when I hold down the red arrow, I can move it on the x-axis, and if I hold the green arrow, I can move it on the y-axis. So you can move on a 2D plane inside of using the move tool when you're in the 2D view. You can see that I clicked the 2D view over there, so that now we're in a 3D view. And this is how a 2D camera looks like. This is an orthographic 2D camera. And over here, I'm just displaying how you can move in a 3D view. If I right-click and I move the mouse, you can basically move the camera around. But this is the orthographic camera. It's just straight. It's not like a perspective camera. Perspective cameras they're kind of like more spread, but this is just straight. So you can only see like a box on the screen. So it's just straight. And this is what you can see. So when you click 2D again, you'll go back into the 2D perspective right here. So that is the 2D perspective. And over here, what I'm going to do right now is I went to the camera component over there, and I changed the camera's color to be black so that it doesn't appear blue. I like it this way. And this is something that I do usually. And now I'm going to demonstrate how you can make this camera come closer. We do not need to look so far. We just need to look at the things that are very close, like over here. So what I'm going to do is I'm going to bring the camera's far clipping plane, which is the range after which the camera starts clipping objects. I'm going to bring it closer. So you can see over there, I just changed the clipping plane to 200, I believe. And now the camera is a little closer. So it can only see things which are 200 meters in front of it. If something is further than 200 meters, it's not going to see it. That's an optimization thing. So the camera doesn't render many things. So there I'm just playing around with the window to see that everything is working properly. Okay, so now I'm going to create a folder by right-clicking in the Project Explorer, which is that, and I will create a new folder over here, and you can see that I named the folder right now. And this is where I'm going to place the assets of the game. Now I'm going to use the free assets that I will find on the internet, and I'm going to use the website called Kenny's Assets, and you can see I'm creating multiple folders. And this is the folder structure that I usually use for simple games. I've got more complex folders as well, but this is the simplest one that I use. And I'm just focusing on that this is the Project Explorer, and this is how you start making folders, and this is how you start organizing your project. So over here, I'm going to search for Kenny's Assets, which is a website where you can download free assets. And by free, I mean free as in freedom. You can do whatever you want with them. You can use them for commercial games, you can use them for non-commercial games, you can use them for videos, you can use them for anything. They're free, totally free, free as in freedom. You can do whatever you want with them, you can customize them, and you can reuse them. I believe you can also resell them, but I'm not sure about that. So this is the asset pack that we will use. This is for the space shooter. And I'm going to download this, and I'm going to put this inside of where I created the Unity project. So now these assets will be inside of my Unity project. And you'll be able to see this when I go to Unity projects, which is my folder where I created the project. And you can see I'm going to the assets, and then I'm going into the folder that I just created a while back. And I will download this asset into that folder. Then I right-click and I extract the file so that it is unpacked. And I'll delete the packed file. Now, when I go back to Unity, Unity is going to import these things. You can see Unity is importing this. It's going to apply its whatever it does on these assets to make them function within Unity. And you can see all of these assets are now part of my Unity project. So that's how you bring any asset into Unity. And now I'm actually searching for what ship I will use, because at the moment I'm treating this project the same way I treat clients' projects, where I assume that the client has given me assets and I need to explore these assets. So over here, I'm looking at their samples. I'm looking at what they have. This is a sample of how these assets should be used. Most assets have this. We're not going to make this exactly, but this is a sample of how things can be used within using these assets. So that's just one game that you can create. You can create many games using this asset, but we're going to create a simple space shooter. So once we go ahead and we'll create a C# script. Now, I'm not going to go in depth into scripting, but in order to create a C# script, you have to have a folder called scripts. You right-click, and then you go to create and create a C# script. So a C# script is basically, C# is a language, and we use that to extend the editor. We are not using pure .NET, which is a framework. We're not using that. We're just using C# to extend the Unity editor and extend its features. Over here, what I'm doing is I'm just changing the quality of the game to very low, so that we don't have any optimization problems. However, this is not really a step that is required to create the game. The step that is required is when you'll download Unity, Unity is going to also install Visual Studio with it, if you don't have it already. This is a little important, that you have to go into external tools, which is in preferences, and select which IDE you will use. Now this IDE, which I'm using, is called Writer. It's a commercial IDE. it is not free. You have to pay for it, but it's much better than Visual Studio in my opinion. And if you need to work fast, you need to use Writer, as it has a lot of autocomplete features that Visual Studio does not have. So I'm going to use Writer to start editing this script. And Writer is by JetBrains. So over here, you can see that I dragged and dropped that component, which now the script actually becomes a component. Whenever you create a C# script, it becomes a component. And I just dragged and dropped it onto the camera, like where the camera component was. And this is how a script looks like when it's created using Unity. It has a start and an update. A start function is the one which starts as soon as you hit play, or as soon as the game object becomes activated in the scene. The update is a function that runs every frame. So usually games have 60 frames. They have 60 frames per second, so this is going to run 60 times per second. This update is kind of like a loop, or a function that is a loop. It continuously runs. It runs over and over again. So what I'm doing over here is I'm going to delete the update because we don't need it on the camera. However, I'm going to use the start function to set the screen size. I'm going to set the screen size, and I'm going to also delete some of the libraries that I'm not using. And you can see that they were gray because I wasn't using them. So over here, if I go over here, I'm going to set the resolution of the game by using screen.setResolution. Now this is a class and that is a function. If you do not know programming, don't worry about it right now. But screen is the class or the data type, and .setResolution, the set resolution, is the function. So I'm basically just telling Unity to set this game's resolution to 1280 by 720 and make it a windowed game. So it runs in a window. That's all I'm doing over here. And this is important so that your game is consistent. And if you do not know about programming in general, don't worry about it. It takes years sometimes to understand how these things work. But this is standard. I do this for all of my games. So this is the resolution that I use. However, sometimes clients tell me to use some other resolution, so I put that resolution over here. Now I'm going to probably start creating the plane. Okay. So what I do is I right-click over on the hierarchy, or I can hit the plus that is over there. And now I'm going to go. I went and I created a 2D object, and the 2D object is a square. Now this is going to be the player. I'm going to replace it with one of the assets that we have in our project right now. So you can see that this is a square, and I'm focusing on this, and I use the move tool to move it in the middle. And you can see that I'm shaking it just so that you know that I'm moving this. And you can see that the square also appeared in the game view, because that's what the camera can see. So once I'm here, I'm going to drag and drop this into the Sprite Renderer Sprite property over there. The Sprite Renderer is, well, as its name suggests, it renders a sprite, and these are all sprites. So what I do is I'm going to, this is actually the background, sorry, this is not the player, this is the background, and I just extend this background using the rect tool, which is this is a rect tool, to extend it so that it covers the entire camera. However, I'm also going to make this a tile. Right now, you can see that it's not appearing very good. It's kind of pixelated. It doesn't appear very good. So right now, what I'm going to do is I'm going to convert the sprite into a tile. Now, what a tile is that just like you have floor tiles, the sprite becomes a tile. So instead of this being stretched, it's just going to be a bunch of tiles. And so it'll look better, because when you have one sprite that is stretched like this, it's going to appear pixelated. So over here, I'm trying to find out where the tiles are, because I don't usually tile sprites. And sometimes when you have a lot of tasks, you forget exactly where everything is. So over here, I'm trying to find out how to convert this into a tile. And I actually find it out over there. But then Unity gives me a warning, and it says that you cannot make this a tile because this sprite is not a full rect. Now, what a full rect is, it's Unity's own thing. Even I do not know what it means, but it just means that the sprite isn't set up for tiling. So right now I'm going to convert this sprite into a full rect, and then I'm going to use the tiling feature of Unity to make this into a tile so it looks a bit better. And this will be the background of the game. And you can see that right now it's starting to appear a bit better because now it will be a tile. Either right now or it's going to be a little, after a while it's going to become a tile. I think it is right now a tile. Okay, so before it was pixelated and then it wasn't. It actually, because of the tiling feature, now you can see that it's not as pixelated as it was before. And the reason for that is because now the background is a tile. And you may need to use the Unity's tiling feature to make sprites for your game as well, because sometimes you have no other option. Ideally, you should have something which is 1280 by 720, background which is 1280 by 720, so it looks prettier, and you can actually tell exactly what you want in the screen. So this is going to be the background of the game. It's going to be a static background. It's not going to move. We are not creating a space shooter where we move up and the background changes, because this is very basic. So this is what we're going to use. So I have made sure that this rect, the camera covers this entirely. And now I'm going to make another 2D sprite. This is going to be the player, most likely. So now I'm going to name this player. I believe I named this player avatar. I don't remember what I called it. But over here, I'm going to, again, go into the assets, and I'm going to select one ship. I liked one of them. I like this ship, I believe. And I just dragged this sprite into the sprite property of the Sprite Renderer. So the Sprite Renderer is the component, and right now, I just dragged and dropped the sprite into that component. When I did that, you can see that the ship is now on the screen right now. It is on the screen right now. And this is basically the ship that we are going to control. And once we have that, we are going to make it a bit larger so that it appears a little cool. So once we have this, we are going to actually set the position of this ship. And I set its x value to 0 over there, because when you have this in the middle, the ship is directly in the middle. When you have the x to 0, so it's directly in the middle. Over here, what I'm going to do is I'm going to add a rigid body and a box collider. So rigid body is going to add physics into the ship, and then we also have a box collider, which I'm going to add later. So box collider is going to enable collisions on the ship. The rigid body is going to add physics into the ship. Now over here, I'm setting some of the properties which you can see, and I set the gravity scale to 0. Otherwise, the ship is going to fall due to gravity. So when the gravity scale is 0, it means the gravity does not affect the ship because it's flying, so we don't need any gravity. So that's what I did. And now I'm going to add a box collider. And once I add the box collider, this ship is going to accept collisions. So a box collider is also a component, just like Unity has other components. That is the box collider. And you can see this green thing that came on this ship, that is a box collider. So basically, it means that you have collisions over here on the ship. And I'm going to actually make this box collider a trigger. So I don't believe that this would be a trigger. Sorry, I apologize. This is not going to be a trigger. This is going to be a box collider, and it's going to be a solid collider. Over here, I'm actually looking at the bounds of the screen. So when I moved it to the right, I'm actually looking at the transform component, and I'm looking at that value over there. That is the value that I'd like to memorize, so that when the ship moves, it doesn't go beyond that point, either on the left, either on the right. Because if I do that, then the ship is going to go off screen. So I'm memorizing that transform property and that value, so that when I create the controller for this ship, when I create the controller, I make sure that the ship doesn't go off screen. It stays on that extreme. And I need to make sure that I remember that. So over here, I created another script inside of Rider, which is called the player controller script. And I'm just going to write a comment which is going to say what the script will do. This is standard practice. So when you have a script, it is a good idea to comment that script so that if another programmer looks at it, that programmer knows what the script is doing. So over here, when you have player controller script, which you have right now, I'm going to add some function. This is going to handle everything that we need for this basic space shooter. Again, it's a basic space shooter. Using the header property, I'm going to tell Unity or the editor that this is what we are adding over here. So you can see that I wrote movement-related variables. This is just to tell the other programmer if he opens up Unity, he or she opens up Unity, they'll be able to see that movement-related variables are over there in the editor. So this is a good practice, and I use it all the time. So the header property, using that, I can tell the editor that these variables will go over here, and then the programmer will also know that these variables will go over here. So you have rigid body 2D over here, and this is actually a data type, which you also saw the component which I added. You can expose this in the editor as well, in the script as well. And the serialized property, serialized field property means I want to expose this variable into the editor so that I can see it. If I didn't write serialized field, then this private rigid body would not have appeared in the editor. It would just be inside the script and I wouldn't be able to see it. So this is so that I can see the rigid body data type that I've created over here, or the rigid body variable that I've created over here in the editor. The region directive is just for organization. You can ignore this if you want, but the reason why I have a region over here is because I want to organize things. So whatever is in the region, I can fold. And you can see I put another region called movement-related functions, and I put this inside a region. So when I'm working, I can actually fold this, and I can concentrate on other things inside of the script if I want. So making regions is also a good idea because you can fold things. And when you fold things, then you'll be able to concentrate only on the things that matter. So over here, I'm creating a function using private void, and I'm going to call it player move function. And this is a function. So this is, we will write the code here which will make the ship move. So this is how I organize my code. The movement-related functions only contain the movement-related functions. And Unity functions I've also written inside of the brackets built in is to tell you basically that these are the built-in functions. I didn't create them. Unity already provides them. In the fixed update, private void fixed update runs 0.02 seconds. After every 0.02 seconds, whatever is inside the fixed update will run again. This is for physics-related functions. Fixed update runs after every 0.02 seconds, and it continuously runs until the game ends. So that you can write all of your game logic inside a fixed update, especially if it's physics-related. Over here, what I'm doing is I'm accessing the horizontal access that Unity doesn't provide that, but Unity has an input class. It has an input class, and when you say .getAccess raw, you're actually telling Unity to get an access which is called horizontal. And the horizontal access is basically left and right. On the gamepad is also left and right, and all input peripherals have a horizontal access. Most of them at least have a horizontal access. So we're telling Unity to access the right and left of any input peripheral over here, and I'm storing that value inside of horizontal input. That's a float. This is a float. It's a data type float. So a floating point, again, that is a programming thing. You can look it up on the internet what floating points are, but they're essentially numbers. They're 0, 0.1, 0.2, 0.3. They're not integers. Integers are 1, 2, 3, 4, 5. Floating points are points, and they're much more than that, and they're not also very accurate. So I go back into Unity, and you can see in the script over here, I don't have any script over here. The player controller script hasn't been attached yet. So what I'm going to do is I'm going to click on Add Component, and I'm going to search for my script that I just wrote. You can see that it's over there, and the rigid body is exposed. You can see I'm even focusing on the rigid body. I'm going to drag the rigid body component into this to tell Unity that this is the rigid body I want to manipulate or I want to use. So I expose the rigid body, and then I drag and drop the rigid body into the variable that I exposed in the script. So when I go back into the script, I'll explain what I did again, just so you understand. And right now, I believe I'm creating another script. Oh yeah, I'm just playing this. So when I play this, you can see that the ship is moving when I hit left and right, but there's a problem. This ship is actually going to leave the screen. And right now, it's also very slow. So you can see it's going to leave the screen. So before I moved the ship, before I wrote the script, I moved the ship to one extreme just to see what the value should be so that it doesn't go off the screen, because it can go off the screen right now. So what I'm going to do is I'm going to refer that rigid body that I dragged and dropped, and I'm going to use its position property. So what I'm doing over here is that rigid body that I dragged and dropped into the script, I'm accessing it, and it has a position property. I'm going to use .position to access that property. And over here, I'm going to use a math function to make sure that the position of the rigid body does not exceed the limit that I've set. So over here, if you can see this rigid body .position, now .position, this rigid body .position has x and y, because it moves in a 2D plane. So over here, I'm telling this that the transform over there, which is that value which I've highlighted, this should remain the same. That's what I'm telling that function, that value that I just highlighted should remain the same by saying this rigid body .position.y, which is the current value, should remain the same, because I do not want to change the y. I just want to restrict the x of the ship. So over here, mathf.clamp. This is a function that is provided by the .NET framework, I believe. Either it's provided by .NET or it's provided by Unity. But what this does is it takes a value and it makes sure that that value does not exceed or decrease the values that you define over there. So it's minus 7.5 and 7.5. So it's always going to remain between minus 7.5 and 7.5. That means that when you're going to move the ship, it's not going to go outside the screen. It's going to remain inside of the screen, because 7.5 and minus 7.5 are the extremes. We're not going to exceed those. So you can see over here, I'm moving the ship, and I'm just making sure that 7.5 was the correct one. And now I'm going to move the ship again using the left and right arrow. And now you'll see that the ship is not going to move off the screen. I tested that, so now we have our ship movement done, basically. And these are all maths functions, and this is how you basically restrict a ship or restrict anything within the bounds of a screen. There are also other methods. You can also use colliders, but I prefer this method as I believe that it's more accurate. And with colliders, you can also have bugs. And another thing that I did over here is I just increased the value. So when I was moving the ship using the velocity property, I was actually giving another value to the velocity of the rigid body. So rigid bodies have velocities, and I'm using the velocity of the rigid body to move the ship, and you can see that it's actually moving using the velocity of the ship. And the last edit that I made, I just made it a bit faster. So instead of just using a raw input, I multiply that input with some number so that the movement becomes faster. Then the game does not appear to be very slow, and it's manageable. So right now I zoomed in to the ship by double-clicking it on the hierarchy. And right now I'm going to create the shoot point, I believe, for the ship. So in order to make a shoot point, I need to tell Unity where the bullet should spawn. So I'm going to right-click this right now, and I'm going to go to create empty. Now, create empty means you're creating an empty game object. It is something that Unity provides. And a game object is, well, it's built into Unity. It's a game object. And I moved this game object slightly above. So it's empty. You can't see anything. But you're not supposed to. This is an empty game object, but you can see its axis, and you can see the move tool. So I move it up a bit. This is going to be the shoot point. This is where the bullet of the ship, this is where it will spawn. So when you have to spawn a bullet, you also have to tell Unity where it will spawn from. Like you can't make it spawn from inside the ship. That'll look strange. So what I did now is I dragged and dropped this entire ship into the Project Explorer so that it becomes this blue prefab. What a prefab is, well, like its name suggests, it's a prefab. So prefabs are essentially game objects that have a structure. So I dragged and dropped that ship into the Project Explorer so that it becomes a prefab. Unity does this automatically. Now I can reuse this multiple times wherever I want. This ship is basically a prefab. I can drag and drop this into multiple scenes if I want. So that then the ship is actually saved. So once this is done, I'm going to create a bullet. Now I preferred the green bullet out of all of these assets. So I took the green bullet, which is over here, and I'm going to drag and drop this bullet into the hierarchy like that. So you'll see that right now it's hidden behind the background. That is because the sprite renderer of the bullet has a lower order than that of the background, or it has the same order. Sprite renderers have orders. So something that has an order of 5 will appear before something that has an order of 4. So 5 means it's in front, 4 means it's behind. So you can see that I changed the sprite order over there, and now you can see the bullet. So, and you can also see that the bullet is actually behind the ship. It's not in front of the ship, it's behind the ship. If I move the bullet down, it's going to appear behind the ship, not in front of it. That's because of the sprite order. And the ship has a sprite order of 5. I believe the bullet has a sprite order of 1. So on the bullet, I also add a rigid body because it needs physics. And I also will add a box collider on this bullet. So the box collider is going to enable collisions, and the rigid body is going to enable physics so that I can use forces on this bullet because it has to move upwards. And that's what I'm doing over here. So I'm just making sure that the rigid body is fine. We don't have any gravity. And we also constrain the rigid body so that it doesn't rotate. It just goes straight. If a rigid body is not constrained, then what happens is if it collides with something, it starts rotating due to physics. So you have to constrain it, which I just did. And over here, I believe I am... All right, so I don't remember what I did over there. But what I'm doing right now is I'm basically I am dragging and dropping the bullet so that it becomes a prefab as well, because we don't want the bullet to be in the scene we don't want it to be in the scene all the time. We want it to be in the scene whenever we shoot or fire. So I make this a prefab. And we're not going to use pooling for spawning the bullet. Pooling is a technique which is for memory management. We're not going to do that since we're making a very basic shooter. But when you produce a game, you should learn about pooling. That's a different topic where you actually store the bullet into memory and then you load it from there so that Unity does not suffer from something called garbage collection, which is a problem in Unity. Okay, so I create another region called shoot functions, and then again a header, just the same as before, and I say bullet reference. So because I created a prefab of the bullet, I also need to refer that prefab. Because that blue saved bullet, I need to refer that. And I need to make sure that I drag and drop that bullet into my script, and then I can load that bullet from there. So this is the reference for that. So private game object bullet reference. Bullet reference is the name of the variable that I've made. And over here, I'm going to say private void spawn and launch bullet, just to make it extremely descriptive. And I'm also going to comment this function so that the programmer, whoever sees this, knows exactly what this is doing. So this is going to spawn a bullet, and this is also going to send the bullet upwards. And you can see it over here. And this is where I reference the shoot point. So if you remember, I created a shoot point, or a point where the bullet will spawn at. This is going to refer that point. And I also have to drag and drop that point in the script so that it becomes, so that we can use it. So over here, again, I'm going to create another game object. Now this is a game object inside of a function, which means it's been created at runtime. this will be created in memory. So this is a runtime variable, which I'm creating at runtime. And I'm going to use the function called Instantiate, which basically means spawn or bring in or create inside the scene. And what I'm going to do is I'm going to spawn bullet reference and the position, you can see over there, shootPoint.position, which means I want to spawn this on shootPoint.position. And quaternion.identity means that we just want to have a rotation of 0, 0, 0, which is basically the rotation property which you see in the editor with the transform. And that is the shoot point. I just focused on that. And you can see that now we will, on the script, we will have shoot point, and we also have the bullet reference. So I'm just going to drag and drop shoot point, and I'm going to drag and drop the bullet into the script. So now the editor knows, or Unity knows, what variables or what data I have to load because of this. So again, I named this variable spawn bullet, instantiated it, told Unity what to instantiate or what to spawn, on what position, and what should be the rotation. The shoot point.position, again, very important, is the position where the bullet spawns. And I already showed that that is the shoot point, that is where it will spawn. So I have to tell Unity that as well. So now I'm going to start fiddling with the bullet, I believe, or I'm just going to use the rigid body. Yes. Okay, so now what I'm going to do is I'm going to use the spawn bullet. This I have to access. So there is a method of accessing the rigid body that I attached on the bullet. So if you remember, when I created the bullet, I inserted or I added a rigid body, and this is how I access the rigid body. I say spawn bullet.getComponent, which is everything is a component in Unity. Get component rigid body 2D dot add force. Now rigid body, the component rigid body you can access a function on the rigid body called dot add force, and it does exactly what it says. It adds a force. So you can see that I said dot add force vector2.up, which means it'll go up, and I also multiplied it and I added an impulse force. The second argument tells Unity what kind of force you want to add. So impulse means immediately, like as soon as it spawns, it's going to immediately send it up. That's what it essentially means. Over here, now I'm not doing this in the fixed update. I'm doing it in the update function, which is also a function that Unity provides. And the reason why I'm doing this is because update runs every frame. Fixed update runs every 0.02 seconds. Update runs every frame, and for inputs, you want to check for an input every single frame. Otherwise, you're going to have problems. Fixed update sometimes misses inputs. So right now, what I'm going to do is I'm going to test the bullet, but you can see it's very fast. It's too fast. There's a lot of force being applied on the bullet, and I don't like that. Another issue is that the bullets are being spawned in the hierarchy, you can see over there, but they're also not being destroyed, which is not a good thing. We want the bullets to be destroyed. Otherwise, your game is going to have a memory leak error. So what I'll do is I'm going to change the property, change the force that I'm adding to some lower value, and I'm also going to call a function called destroy, which is given to me by mono behavior, which you can see up there. You can see it right now, but mono behavior provides destroy. And I'm going to take this bullet, and I'm going to tell Unity to destroy it in I can't read it properly, I think 3.5 seconds. So what's going to happen is that the spawn bullet is going to be destroyed after 3.5 seconds or whatever seconds I've given over here. So this means that whenever a bullet is spawned, it's going to get destroyed after a few seconds. Now the bullet is too slow, but you can see that the bullet will be cleared in the hierarchy. You can see that's being destroyed because of the destroy function that I called. So I'm just testing the physics, and after that I'm going to change the value of the bullets again, the add force value, so that we don't have very slow bullets, because then the game wouldn't be very interesting. So I changed this to a higher value just so that the bullet is slightly faster. So that is our basic player that we have created. Of course, the bullet is not really doing anything at the moment. It's just firing upwards. So we also have to put some functions in that. And we have to make sure that when the bullet collides with an enemy, that enemy actually gets destroyed. So we're going to take a look at that now. So the first thing that we need to do is we need to tell the game how to spawn enemies. We can't just have some enemies and just 5 enemies, make them, and then just make the game have just 5 enemies. We need to make sure that that the enemies are spawned randomly and at random locations. So we'll work on that. But right now I'm just showing that this is very consistent. Every time I press the space bar, it's going to, the bullet is going to spawn. And that's what I was showing. And again, when you take a look at the script, you'll see input.getButtonDown jump. It said jump, which is actually spacebar in Unity. Usually the spacebar is used for jump, but right now we're using it for shooting. So now I'm going to create another game object. This one will be for enemy spawning. However, I'm not going to work on this right now. I'm going to work on this later. I'm going to move it using the transform properties over there, and you can see over there that I'm manipulating the transform property on the top right. And the rotation is going to be 0. We don't need any rotation. But inside of this, I'm going to create the spawn points. So this is the container of the spawn points, and we're going to have some spawn points inside of this container. So I right-click this and I create another empty game object. And you can see that another empty game object was created. You can't see it because it's empty. But it's over here. Trust me, it's over there. And I'm going to name this spawn in brackets 1. I'm going to click Control-D to duplicate it and make another spawn point. I'm going to move this to 2. So we are going to have one spawn point at 0, one at 2, one at 4, and one at 6 on the X. And then we're going to have another 3 spawn points, -2, -4, and -6 on that side. So we are 0, 2, 4, 6, 0, -2, -4, -6. So this is what we're going to have, and you can actually see it. See the move tool. You can see when I click on a spawn point, you can see that it's moving like that, because that's how I placed it. So this is where the enemies are going to spawn, and we have like a gap of two Unity units, which is the gap that we have, and I believe it makes the most sense so that the player can move around. And you can see this is in the minus. So that was 0. If you're 0 over here, this will be positive, this will be negative, just like just like a normal vector. So now what I'm going to do is I'm just going to create a script which is going to be called enemy spawner script. And this is going to be responsible for spawning the enemies, but I'm not going to work on it because I don't have any enemies right now. I'm just going to set it up so that you can understand how arrays are handled within Unity, or data structures are handled within Unity. So I'm going to drag and drop this over there after I've created it, because every script is essentially a component in Unity, and I'm going to edit the script. Now, how I edit it is just like I did other scripts, but what I'm going to do is I'm going to use something called an array this time to store those spawn points. Now, those spawn points are there, but Unity does not know what to do with them. So I have to tell Unity what to do with them. So what I do is I refer those spawn points just like I referred the rigid body, the shoot point, and the bullet. I'm going to refer those spawn points, but those spawn points are not they are not prefabs, as we don't need prefabs. You're not going to use the spawner, the enemy spawner again. So I need just one enemy spawner in the scene, and that's it. And I tell the programmer using the summary what the script is going to do. Over here, I'm going to start referring those spawn points. But right now, I'm just going to refer the spawn points. I'm not going to refer an enemy because I don't have an enemy. We have to create the enemy. So again, I start by using header, start by using region, and then I place a header inside of it. And this is again for organizing. You don't really need to use this, but I do it all the time because sometimes my scripts can be as large as 2,000 lines of code, and it becomes quite difficult to navigate and find functions. So over here, I set the property, the attribute header, and set it to spawning related variables. And over here, you can see that private transform, and there are square brackets. This tells Unity that this is going to be an array, which is a bunch of stuff, just not one game object. It's going to be quite a few game objects. But this is transform. This is not a game object. I want to access the transform property of the spawn points because transform has a property called .position. A game object also has that. Game object has a property called transform, which has a property called position. But I'm going to refer transform just for efficiency. So I made an array transform of transform type, and I'm going to call it spawn points. And now I also have enemy types. I forgot to make this an array. I'm going to correct that later. But this is going to be enemy types array. And over here, I will run a routine. This is not going to be an update. This is going to be a routine because I want to spawn the enemies at various times. It's not going to be as one single time. It's going to be a random time. So for that, I need to run a routine. So routines in Unity are, well, they're routines. What happens is routines run on a secondary thread. They run on another thread, not on the main thread. What routine does is you can actually tell the routine when to run. You can run it again and again using a while loop, which is something in programming that we use. But in a routine, you can tell that while loop to run at certain times. So over here, you can see that I'm using a Boolean. Boolean is a variable that has the value of either true or false. That's all you need to know. It either has a value of true or false. It is used for logical programming, and I set it do spawn is equal to true. That is the value. So as long as do spawn is true, this while loop is going to run over and over again. If it's false, it's going to break. It's not going to run again. This is just for that. So over here, I say yield return new wait for seconds. This is just syntax. You don't need to know what it does. But just remember that whenever you need to wait for certain seconds, you need to have a private I enumerator and then yield return new wait for seconds. And then I use random.range. Random.range is provided by Unity, and I'm going to tell Unity to wait for seconds in between that range that I've given. So whenever that while loop runs again, it's going to wait for a random amount of seconds, which is being returned by this function over here. So the enemies are going to spawn at a random time. And again, this is a basic space shooter. There are ways to optimize this. We're not going to go over that. This uses a little bit of unnecessary resources, but since this is basic, this is what we're doing. Now, over here, I'm using the same method, instantiate. But this time, because that is an array, I want to get a random point from that array. So what I'm going to do is enemy array. Then again, I need some value of that spawn point, like the spawn points that I have. I want to get a spawn point from that array. So what I do is I again use random range, which will start from 0 and end at the enemy array.length. So if the enemy array is 7, then I don't want it to exceed that limit. Otherwise, we're going to have an error because Unity will say there's nothing on that index. What am I supposed to do? So this is what I do. Dot length is simply going to make sure that you don't end up getting something that doesn't exist. And spawn points, again, instantiate, I have to give the position. So in spawn, over here in spawn points, I'm actually giving the position. Again, spawn points is a transform over there, and I'm getting the position, a random position, using those spawn points. So I created the spawn points in front of you. This function is simply getting a random spawn point and getting a random enemy type, and just telling Unity to spawn a ship in one of those random spawn points, and also a random enemy type. That's what we're doing. So you can see it's over there. That is a script. You can see that there is an arrow which basically means you can unfold this and fold this. That is an array that you see over there. And if you take a look at spawn points and enemy types, you'll see that this is what I was talking about. So I lock this component, and I drag and drop the spawn points over there. And once I drag and drop them, you can see that these are the spawn points. All of them are now inside of the script. So this will basically tell the game what position the enemy is going to spawn in. So you can see that these are the spawn points. And because we have a random range, it's going to take one of those spawn points and use that to spawn a random enemy. Now, I'm not going to set enemies right now because, again, I don't have enemies. We're going to create them right now. So once we go over here, we are going to actually use the UFO type enemies because I dislike aliens. So I'm going to basically use a UFO. And yeah, it looks like a donut. But this is what I'm going to use. So enemy, I'm going to name this enemy type 1 because this is going to be the first enemy type, and the rest of the enemies are going to just have different colors. They're not going to have any different function. They're just going to have a different color. So again, I'm going to add a rigid body. I'm going to add a box collider. I'm going to do the same thing that I did with the other components. I'm going to do exactly the same thing. I'll make sure that it has no gravity because I don't want the UFO to fall. There's one thing though that will be different in our game. UFOs, according to lore and according to what people say, they can fire in all directions. So our UFOs are also going to fire towards the enemy. They're not going to fire only like their bullets are not going to travel downwards. They're going to travel towards the player. So that is something that we are going to do. So we are going to calculate the direction of the bullet, and we are also going to make it fire towards the player. And you'll see that I'm actually going to catch some errors, and I'm also going to correct them at runtime. So right now what we do is we are going to set this to enemy type 1, which you see over there. And this is just for organization. Now we're going to create a script for enemy type. And you can see that we have, instead of a box collider, I used a circle collider. And then I was thinking about adding a shoot point again, just like we had on the player. But then I realized that it's a UFO, it doesn't need a shoot point. It can just shoot its bullets from its center, and people will probably think that it's still shooting from its side, although it's not. But we will not have a shoot point on the UFO. We just think that it has a turret underneath it, so it's going to shoot in either direction. So we will not have a shoot point. So what I do is I'm just checking the components to make sure that everything is in order. And now I'm going to go ahead and start creating the script, which will be called the enemy controller script. So I'm over here. I'm going to go to create a C# script, which is going to be called enemy controller. And this enemy controller is just going to make the ship come down. The main point in the script is going to be, the main function is that it's going to shoot the bullet in the direction of the player. That is going to be the main feature of the script. Other than that, there will be nothing special that we'll do on the script. I have also created this into a prefab, I believe. I have, or have I not? Anyway, if I haven't, this is going to be a prefab. The enemy type is also going to be a prefab. And what I did is I dragged and dropped the prefab player bullet, you can see it over here, into the scene so I can break this. What I did is I dragged and dropped the prefab, and then I broke the prefab because I need to create a new prefab. This is going to be the enemy bullet now. So I used the prefab from the player bullet, broke it so that the changes that I make do not affect the player bullet, and now I'm going to find a bullet for the enemy. So this is that reusing thing that I was talking about, that you can use the prefab to create other prefabs or to reuse the prefabs. So I'm now searching for any sprite that I believe will suit the enemy bullet, and I found one, so this is what I'm going to use. You can see that the box collider and rigid body that was being used by the player bullet is also being used over here. So that decreased my work, and that is a good thing, because that's what, as a programmer, you should do. You should always think about reusing stuff that you've already made. So once I do that, I'm going to create this into a prefab by dragging and dropping it over here. So now we have player bullet and we have enemy bullet. And I'm also going to delete this enemy bullet because I don't need it in the scene. So I'm going to just take a look at enemy bullet, and what I'm going to do is I'm going to delete it from the scene I'm just making sure that I don't end up doing something wrong. Okay, so now enemy type. What we're going to do is we're now going to, I believe, start editing. Oh yes, to test the enemy, we are going to move it off the screen. So we want to test its movement first, so we're moving it off the screen. Over here, what I'm going to do is I'm going to, again, refer the rigid body, and we're going to do the thing that we did with the player, except that we're going to tell this UFO to travel downwards. We don't want it to move left and right. We just want it to move downwards as soon as it spawns. So right now, assume that the ship is going to spawn, the UFO is going to spawn, and it's going to travel downwards. And when it's traveling downwards, we want to test it before we start with the spawning script. Because if we spawn before testing it, then if we have errors, we'll have to fix those errors and wait for the ship to spawn. So before the ship spawns, I want to test it to make sure that everything is working properly. So over here, I'm going to make another region called enemy movement functions. And now I'm going to call this move enemy towards the player. And it's not going to really move the enemy towards the player, it's going to move it downwards. I should have named it move UFO downwards, but I named it move enemy towards the player. And again, I have a header property, and in that header property, I'm going to like refer the rigid body that is attached to the UFO, which we did before. So once the rigid body has been referred, I'm going to drag and drop it, just like we did in the previous script, in the previous scripts, and we are going to move from there. So I'm going to refer the rigid body and say dot velocity, and then we are going to say, okay, so I mean, we didn't really miss anything. Is that I basically created the dot velocity, access the dot velocity property of the rigid body, and then I simply told it to move down. That's all I did. So hopefully when we play this is the UFO is going to come towards the player, and I'm playing it, but there's a problem. I forgot to refer the rigid body. So you can see that I actually have an error right here because I forgot to refer it. So now I'm going to drag and drop the rigid body into the script, and now it's going to function. That is the first error that we have because I forgot to refer it. So Unity did not know what to do. Now again, another error, instead of sending it downwards, I sent the UFO upwards. So I myself was confused over here, it's moving upwards. So what we'll do now is we're simply going to change this to minus. So dot velocity is equal to new vector 2. I'm just going to move it downwards. So the velocity will now be downwards, not going to be upwards. So when we are going to click play, this is going to move downwards like that. So the UFO is going to travel downwards. And of course, it's going to hit the player and it's going to create bugs because we haven't handled that. But this is how it moves downwards. And since it had physics, it was actually pushing the player when it collided. That's the proof of physics right there. Okay, so now that we have all of this, we are going to start with the shooting functions. So I believe we're going to do shooting right now, and then we're going to do the destruction of the enemy of the ship. So enemy destroy script. Now there's a reason why I'm doing destroy before, because handling destruction and handling the destruction of the ship can be problematic if we don't handle it right now. So instead of shooting, I decided to do the enemy destruction functions first. So in order for the enemy to be destroyed, we also need a fancy effect. So I don't have that effect right now, but I'm going to create the reference for that so that when I do have the effect, I can simply drag and drop that and it's going to work. So I don't have that right now, but I have created a reference for that right here, private game object, destroy effect, which is the name of the variable. And over here, I'm going to create destroy this enemy, which is a function. And it's an empty function. I'm going to call this into in a Unity provided function called onTriggerEnter2D, which basically is a is a function that Unity provides. If your game object has a collider, when on trigger enter, whenever that collider enters a trigger, that function is called. This is something provided by Unity, and it's provided by other game engines as well. Unity just has its own on trigger enter function. Most engines have this trigger mechanic. Even an open source engine like Godot has it. So before that, what I did is I used something called a tag system. And to use the tag system, what I did is I went to the player bullet, and I set the tag. There's a property on the transform, on top of the transform, where you can set the tag. So you can basically set a tag, or it's kind of like a label which you have on a bottle. And that label tells Unity what object it is. So over here, what I'm doing is private void on trigger enter 2D, and I say .compare tag. So what I'm telling Unity is that if you collide with a trigger and that trigger has a tag called player bullet, then it means you have collided with a player bullet. So when I collide with a player bullet, I'm going to call destroy this enemy, and that's where I'm destroying the enemy. And I'm also just having a print statement. I wrote a print statement over there, so I can see in the console that this ship is being destroyed. So this is how you destroy the ship. Again, trigger will check whether whether the collision will happen with the player bullet, and if it did, then we are going to destroy the ship. So we're going to test that right now, and once it works properly, I'm going to basically move forward with the enemy spawning, and then I'm going to move forward with the enemies shooting at the player. So I'm just making sure that everything is okay. And when I click play, hopefully this is going to get destroyed, and there you go. It got destroyed. But there's another thing too, that the bullet that collided with the UFO, that didn't get destroyed. So we have to handle that as well. So in order to do that, again, we have the collider data over here. So what we're going to do is we're going to simply use the collider data to destroy the bullet that collided. So what we're going to do is, since collider is attached to a game object, we are going to say destroy collider.gameObject. So that means whatever collided with this object, that should be destroyed, because collider is attached to a game object, so you can access that game object property as well. So this is what we're doing, and I'm also commenting this so that the programmer, whoever looks at this, knows exactly what's going on. So player bullet, if the ship collides with a trigger that has a tag called player bullet, we're going to destroy the bullet, and we're also going to destroy the ship. This is essentially what it's doing. And again, this is, when I started, it took me a while to understand all of these things, but this is pretty standard. You don't need to, you can basically just memorize that this is how it works. So now when the bullet collided, it got destroyed and the ship got destroyed. We don't want the bullet to just travel and destroy 10 ships in a row. So that's what this did. So once a bullet collides with the ship, it's going to get destroyed. So I believe now I'm going to work on the effects, because I want the ship to be destroyed with a cool effect. So we're going to learn a bit about animation, just a basic animation. And again, I just drag and drop this effect, which is, well, it's not really an effect, it's basically a sprite. And it's just this star. And what we're going to do is, when the bullet collides with the ship, it's just going to expand and contract this little effect that we have on the screen right now. I'm still looking for other effects. I thought that we could probably use something else, but this is the one that I believe makes the most sense right now. So what I did is I basically took this little effect, and I used the scale tool, which you see over here. That is the scale tool, and I click this and I scale this so that it becomes a little larger. You can even see that in the game view. And once I have that, what I'm going to do is I'm just going to drag and drop this onto the enemy ship, just so that I get an idea of how it looks like when it's behind the enemy. So I just scale it a bit using the scale tool again, which is I change the size, and then I move it behind the enemy, just so that I can get an idea of how it will look like once it explodes. That's what I do. And now I'm going to create another folder which is going to store the animation which we will use for this effect. So it expands and contracts, so it creates this cool destruction effect. So I'm just going to call this destroy effect, and this will be reused over and over again. So I'm going to make this a prefab, and I'll drag and drop this soon into the project explorer. But before that, I'm going to create animations. So what I'm going to do is I'm going to create an animation folder, and I'm going to right click again and go to create, and then I'm going to create an animator controller, because for animations you need an animator controller and then you need an animation in Unity. There's a simpler way to do this, but this is the standard way that's being used everywhere, where you have an animator and then you have an animator controller. So now you have an animator controller, and you're going to drag and drop the animator controller so the animator component is automatically added. Usually what I do is I insert the animator component first, and then I drag and drop the controller into the controller property. But this time I didn't do that, just to save a bit of time. So once I have the animator controller, and now I'm going to create an animation. And in case you don't see these windows, if you don't see them, the animator window and the animation window, you can always go to window over there on the top, right next to help. There's a window menu. You can use that to actually open up these windows. So the animator window looks like that. Those are the states. I'm not going to go into a lot of detail, but over here I'm showing that if you don't see them, then you can actually open up the window and then find these windows, which is the animation animator. Now what I did is I dragged and dropped the animation, the empty animation that I created into this window, and this animator controller was attached to the destroy effect. So now we have an animation. What we do is, when we have an animation, we click the record button over here, and whatever we do to this destroy effect, it's going to be set as an animation over there. So all I did is I basically used the scale tool to scale it down a bit, and then I scaled it up again. And now I'm going to scale it all the way to 0, so that disappears from the screen. So that's all I'm doing. So over here you'll see that I created this, and now I'm going to play it, and now you can see that it's kind of like expanding and contracting. So that's what I did, and I'm actually checking this because I found some kind of an error. I don't remember what it was, but it was probably that the animator was getting stuck somewhere. So then I deleted because I have a prefab now. So now that we have a destroy effect, all we have to do is we have to spawn it when we have destroyed the ship, or before we destroy the ship. And then we also need to destroy that effect so that it doesn't eat up all the memory that your computer has. So for that, I will create a new script. And there is another way to do this, but for some reason I could not find it. There's a way to destroy game objects after they're spawned. I just didn't remember how to do it at that when I was creating this video. So you don't need to make a script for each and every object. There's a simpler way to do it. I just don't remember what it was. So what I do is I drag and drop that script which I just created, which is the destroy effect script, and I just edit it. And all I'm going to do is I'm going to destroy this effect after it is spawned. So that's all I'm doing. That is the only thing that I'm doing. So destroy, I'm going to just use the game object property, which of course this is a component. So all components have access to the game object property. I'm just going to destroy it after 1.5 seconds. That's all I'm doing. And we're done with the destroy effect script. So once that is done, we're going to go back into Unity, and we're going to refer that destroy effect in the enemy object. So we are going to find the enemy object, and then we are going to simply drag and drop it into the reference that we created. So you can see that is the enemy object, and I'm just going to drag and drop it into the destroy effect reference. But it's there, but we do not know what to do with it because Unity does not know what to do with it. So what we're going to do is we are going to use the instantiate again, which is spawning, and I'm going to spawn the destroy effect where the enemy died, and and also set quaternion.identity, which means that set all the rotations to 0, 0, 0. So that's all that we do. So once that is done, we are going to go and test it, and we're going to see how it feels like and how it looks like. And once I'm going to click play, you'll see the destroy effect happening in front of you. And there you go. So there's a destroy effect. So what I did is when I destroy, I spawn the destroy effect, and that's basically the basic player mechanic to shoot the UFOs. Now, I make some edits over here, but that is just to make it look better. This is nothing to do with the functionality of the game. It's just these are some edits that I made on the keyframes. Now keyframes and this animation at the animation window, I can go like there are a lot of details that I can cover, but we don't have time for that. But you can take a look at this later. And you can see that this is being destroyed, and I feel like this is the destroy effect that we should go for, but I changed the properties again just because I thought that it was a little small when it was being destroyed. So that's what we do, and then we test it again. So this is a problem. Whenever you make an edit, you need to test it again and again just to make sure that it works. So there you go, that's the destruction effect. So that is your basic player controller for the UFO. And how much time do we have? I guess I'll have to stop over here because we have to do the question and answer as well. It's going to take more than 15 minutes to cover. So this is the basic. At least we have covered the player shooting mechanics. What we didn't cover is the spawning and the shooting of the player towards the enemy. So the shooting of the enemy towards the player. And we also didn't cover spawning because of time constraints. There is no short way of doing this. We had to go through the entire process. But at least we know the basics of how to create a player, how to move them, how to clamp them, and how to shoot and create another enemy, which will basically shoot the player. So you can do the opposite. What I did for the player, you can do that for the enemy, and it's going to basically start shooting. The only thing that I wanted to cover was the spawning, but we don't have time for that. So that's all we can do.
I wanted to ask, what does it mean when we use the term refer in Unity?
Okay, so references are basically like if you have a script, you create a data type, or you create rigid body or transform or whatever you want. So when you say reference, what I'm saying is that we're exposing that variable in the editor, so you can refer it later. So it's kind of like a pointer. So if you have something in the hierarchy or in the Project Explorer, and if you have a rigid body, let's say, or you have a transform, or you have any game object, you want to tell Unity that you have to do this with this game object. So when you expose it in the script, and you drag and drop that game object into that script, you're telling Unity that this is the game object that we're referring to. So, like for example, if you want to spawn a bullet like we did, we need to tell Unity which bullet it has to spawn. So I had to refer that bullet, and I referred that by exposing that variable inside of the script. That's what it means.
So if we have to design a game in 3D, is the process going to be similar?
It's going to be exactly the same, except that you have a z-axis. And 2D games use rigid body 2D. 3D games use rigid body. The components are different. The components are different. The only problem with Unity is that Unity does not have a dedicated 2D renderer like Godot has. What you saw was actually a 3D game which was faking to be 2D. It was faking. It was fake. It wasn't real 2D. It was fake. You even saw it that when I clicked the 2D, it actually you could see the 3D. It's faking It's not real.
Yeah, somewhat like SketchUp. You can fake in SketchUp also. But in 3D, won't we have to give up the static background thing? Because obviously the background won't be similar because we're just moving all
If
around.
you have a 2D like a 3D game, well, you can create 3D like you can use 3D models even over here. You can use them, but I prefer a perspective camera. You can have a static background on in a 3D game as well, right? But it can be a 3D background. But if the camera is positioned the same way, even if it's perspective, it's going to appear fine. I've seen this in games like in mobile games. There are certain games where I believe that it was 3D and it was similar to what we have, but they were using 3D models, they were not using sprites. And some of them had static backgrounds. Most of them were moving, but some of them had.
What's the difference between 3D model and the sprites?
Sprites are basically that's just a term. Sprites are just if you have 3D models, you have polygons. Sprites are just data which tell the computer that this is how the pixels should appear like. That's all.
Okay, so is it possible to design models in Unity, or do we always have to import them?
It is possible to design very basic models in Unity, like environments using ProBuilder, but it's not recommended. It's good for prototyping. There's a tool called ProBuilder. I never used it. It is used for prototyping. The reason why on a YouTube video I found that you cannot use ProBuilder for making a complete game is because if you use ProBuilder to make a game, you are telling the computer to do more than what is required because ProBuilder is not optimized for games. It is just optimized for prototyping, quick prototyping. So it's recommended that you make models and then import them into Unity with textures.
How much programming does one have to know in order to use Unity and write the script?
Well, writing the script, there are so many templates that you do not need to know about basic programming. You need to know basic programming, of course, but for advanced stuff like, for example, if you need to know how to trigger an event at a certain time and when to trigger other events and how to use logic to come up with a solution. For example, if you have a laser which is pointed towards the player and you need to have a variation of that laser so that sometimes the player misses, you need to know advanced programming for that, as you need to program the randomness and how the randomness would feel like and how much will that laser be realistic if you take a look at the sniper. That's advanced programming, but for basic, like what you could do is you could just memorize this and you'll have a game. You don't even need to know the logic behind it. But it is a good thing that you know about it. For example, routines. Like I used a routine which was for enemy spawning. We didn't use it. But you should have an idea about what a routine is, what yield, return, you wait for seconds means, because you might need to use it in the future where if you are working for a client, you need to retrieve something from the back end, so you also need to use yield return because you're waiting for the server to give an answer. So it's similar to that. So for that, you need advanced programming. You need to know how things work.
So my question is, it's worked as a mobile app or not?
Well,
It's just a desktop game, or we can say it runs on Android app and just like that.
Unity is a cross-platform engine. Once you build the game, you can create binaries for various platforms, including Android, iOS, WebGL, Linux, macOS, and Windows. So you can create the binaries for those.
So it's not a 3D, as you have mentioned, it's not a 3D platform that we can't design a 3D app over there.
You can you can design a 3D app on it.
Yes.
But this was 2D space shooter.
It was as you have said that it's not a 2D app.
Oh yeah, it fakes 2D. Like
Yes.
the camera, it doesn't have a dedicated 2D renderer. It doesn't have a dedicated 2D renderer. It uses a 3D renderer and fakes 2D.
Okay.
Like you still had a z-axis. In the game that we were making, you had a z-axis. You could even see it in the transform components x, y, z.
Yes.
You should have a z in 2D.
But we can't access that z-axis.
You can if you want to.
We can or we can't?
We can.
Okay.
We can, but we didn't need to because we were using a 2D game.
Hmm.
We were making a 2D game.
So thank you, sir.
Done? All right. Thank you.